Question 1. Which radiation has the highest energy? Option A, radio waves. Option B, visible light. Option C, X-rays. Option D, infrared. Take a few seconds to decide. The correct answer is option C, X-rays. Let's understand why. X-rays have a much higher frequency compared to visible light and infrared. That's why they carry more energy and can penetrate materials more effectively. Question 2. Which best describes the origin of characteristic X-rays during production? Option A, electrons change orbits within the tungsten atom after ionization. B, produced from neutron decay inside the target. C, formed by nucleus to nucleus collisions. D, result from compressed electromagnetic fields. Choose. The correct answer is option A. Characteristic X-rays are produced when a high-energy electron ejects an inner shell electron from a tungsten atom. An outer electron then fills the vacancy, and the energy difference is released as an X-ray photon. Question. X-rays belong to which region of the electromagnetic spectrum? Option A, between ultraviolet and gamma rays in energy and frequency. B, lower than radio waves but higher than microwaves. C, same as visible light. D, higher wavelength than gamma rays with low penetration. Choose the correct answer. The correct answer is option A. X-rays lie between ultraviolet and gamma rays in the spectrum. They have higher energy than ultraviolet but lower than gamma rays. This gives them strong penetrating power. Question 4. Which statement accurately describes Bremsstrahlung radiation? Option A, electrons slow near the nucleus, releasing energy as photons. B, from inner shell electron transitions only. C, occurs only above 1.02 mega electron volts. D, produced only in radioactive decay. Choose the correct answer. The correct answer is option A. Bremsstrahlung radiation is produced when high-speed electrons pass close to the nucleus. They are slowed down or deflected, and the lost energy is emitted as X-ray. Question 5. Which part of an X-ray tube controls focal spot size? Option A, focusing cup. B, high voltage transformer. C, rotating anode. D, collimator. The correct answer is option B. The focusing cup directs and concentrates the electron beam toward the anode. This controls the size of the focal spot and helps produce a sharper X-ray image. Question 6. Which factor mainly affects the energy of characteristic X-rays? Option A, tube current. B, atomic number of the anode. C, vacuum level. D, exposure time. The correct answer is option B. The energy of characteristic X-rays depends on the atomic number of the anode material. A higher atomic number means greater binding energy of electrons. So, more energy is released when electrons transition between shells. Which component in the X-ray circuit adjusts the filament temperature? Option A, autotransformer. B, filament transformer. C, high voltage generator. D, rectifier. The correct answer is option B. The filament transformer supplies low voltage and high current to heat the filament. This controls its temperature and regulates the number of electrons produced. What is the primary mode of heat transfer in a rotating anode X-ray tube? Option A, conduction. Option B, convection. Option C, radiation. Option D, evaporation. The correct answer is option C, radiation. In a rotating anode X-ray tube, most heat is removed by radiation. The hot anode emits heat in the form of infrared radiation, which is then absorbed by surrounding structures. What is the process by which electrons are emitted from the X-ray tube filament? Option A, photoelectric emission. B, field emission. C, secondary emission. D, thermionic emission. The correct answer is option D, thermionic emission. Heating the filament causes electrons to escape from the metal surface. This happens because thermal energy overcomes the binding forces, allowing electrons to be emitted toward the anode. What do we call a discrete bundle of energy in the electromagnetic spectrum? Option A, wave. Option B, quantum. Option C, electron. Option D, proton. The correct answer is option B, quantum. A quantum is the smallest discrete unit of energy. In electromagnetic radiation, this energy is carried as photons, each having a specific amount of energy. What effect does the anode Heal effect have on a radiograph? Option A, increases magnification at the center. B, reduces characteristic radiation. C, causes uneven beam intensity. D. Decreases subject contrast. The correct answer is option C. The anode heel effect causes variation in X-ray beam intensity. The intensity is higher on the cathode side and lower on the anode side. This results in uneven exposure across the radiograph. Which statement describes the line focus principle in an X-ray tube? Option A. Uses a small anode angle to reduce effective focal spot. Option B. Uses a steep angle to enlarge focal spot. Option C. Changes filament shape to reduce intensity. Option D. Reverses electron flow for dual focus. The correct answer is option A. The line focus principle uses an angle anode target. This makes the effective focal spot smaller than the actual focal spot. It improves image sharpness while maintaining heat capacity, which parameter mainly controls X-ray beam energy and penetration. Option A, kilovolt peak. Option B, filament current. Option C, focal spot size. Option D, exposure time. The correct answer is option A, kilovolts peak. Kilovolts peak controls the energy of the X-ray photons. Higher, kilovolts peak increases their penetrating power, allowing X-rays to pass through denser tissues more easily. What is the main function of the glass envelope in an X-ray tube? Option A, focuses the X-ray beam on the patient. B, maintains a vacuum to prevent electron collisions. C, provides a path for high voltage current. D, cools the anode continuously. The correct answer is option B. The glass envelope maintains a vacuum inside the X-ray tube. This prevents electrons from colliding with air molecules, allowing them to travel efficiently from cathode to anode. What is the main purpose of oil surrounding the X-ray tube assembly? Option A. To amplify the electron beam before it strikes the anode. B. To maintain vacuum integrity within the tube. C. To convert scattered photons to visible light. D. To insulate and facilitate heat dissipation. The correct answer is option D. The oil around the X-ray tube insulates high voltage parts and helps dissipate heat, preventing overheating and protecting the tube. Thanks for watching. Stay tuned for more radiology MCQs and detailed explanations. Don't forget to like, subscribe, and share for more content.